The focus of this video lesson is driving data. Example 1. A car travels at an average rate of speed of 50 miles per hour for 6 hours. How far does this car travel? The first thing we must recognize is the formula for calculating distance given a specific rate of speed. We know that we have distance is equal to our rate, or how fast we're moving, times the time we travel. So algebraically, that is d is equal to r times t. Now in this case, we know a couple of things. We know our rate, so that's our r, which is 50, and we know the time, our t, which is 6 hours. So that gives us d is equal to 50 times 6, or d is equal to 300 miles. So this car travels 300 miles. And that's it. Now it's your turn to try. Try this. A car is traveling at r miles per hour for m minutes. Write an algebraic expression for the distance traveled. Be really careful because one of these is in minutes and the other's in hour. So you will have to do conversion. Give it a try. Example 2. Byron lives in New York and will be attending a college in Atlanta, Georgia. The driving distance between these two cities is 883 miles. Byron knows that the speed limits on the highways he will travel will vary from 500 miles per hour to 65 miles per hour. He figures that he will average about 60 miles per hour on his trip. At this average rate, for how long will he be driving? Express your answer rounded to the nearest tenth of an hour and to the nearest minute. All right, so first thing is we know how far this distance is. So that is 883 miles from his hometown to the town he plans to attend college. We also know that distance is equal to rate times time. In this case, we know his distance. We know that is 883 miles. And we know the rate. On average, it will be 60 miles per hour. What we don't know is how long, the time. So let's plug in what we know. For D, we have 883. For the rate, we have 60 miles per hour. And time, we're going to use T since we don't know it. Now our objective is to solve for T, or find the time, so we will divide by 60 on both sides of this equation. Using our calculator, we have 883 divided by 60, which is 14.716 repeating. Okay, so 14.716 repeating. Okay, now we want our answer to the nearest tenth of an hour and ultimately to the nearest minute. So we have here 14 hours, and then we have this 0.716 repeating, right? So let's go ahead and let's figure out how many minutes that is. So I had 883 divided by 60. I'm going to remove the 14 hours, and then I'm going to multiply that by 60 minutes in an hour to figure out how many minutes that is. So it's 43 minutes. So I'll show you one more time what I did. 883 divided by 60 is 14.71666 repeating. Remove the 14 hours because we know that we have full 14 hours. That gives us 0.716 repeating times 60 minutes per hour gives us the 43 minutes. So we know that it is 14 hours and 43 minutes. So it will take Byron that amount of time. So it will take Byron 14 hours and 43 minutes. Now it's your turn to try. Try this. Danielle drove from Atlanta to Georgia to Denver, Colorado, which is a distance of 1,401 miles. If she averaged 58 miles per hour on her trip, how long is her driving time to the nearest minute? Give it a try. Example 3. Kate left Albany, New York to travel to Montreal, Quebec. The distance from Albany to the Canadian border is approximately 176 miles. The distance from the Canadian border to Montreal, Quebec is approximately 65 kilometers. If the entire trip took her about 3¾ of an hour, what was her average speed for the trip? All right, so the first thing I want to do is I want to kind of sketch this out, right? So we have Albany to Montreal. And in between, we have the border. So Canadian border. Now she goes from Albany to the border, from the border to Montreal. We know that the approximate distance from Albany to the border is 176 miles. And we know the approximate distance from the border to Montreal is 65 kilometers. Now, we have a slight issue here in that we have two different forms of measurement. Now, in Canada, they use kilometers to measure their distance, and in the US, we use miles. So we're going to need to do a conversion. Doing a quick Google search, we can see that there is 1.60934 kilometers per mile. All right, so let's go ahead and convert our kilometers to miles. So we have 65 kilometers divided by 1.60934, and we see that 65 kilometers is about 4.4 miles. 40.4 miles. So we have here 40.4 miles. So let's get our total distance, which is 176 miles plus 40.4 miles, which gives us 216.4 miles. Now remember, we know that the distance is equal to the rate times the time. Our distance here is 216.4. The rate is unknown, and our time is 3¾ of an hour, so 3.375. We're going to solve this equation for r by dividing by 3.75 on both sides. So that gives us 216.4 divided by 3.75, or about 57 miles per hour, 57.7. So r is equal to 57.7 miles per hour. So we would say then, on average, Kate was traveling about 57.7 miles per hour. Example 4. Juan has a hybrid car that averages 40 miles per gallon. His car has a 12-gallon tank. How far can he travel on one full tank of gas? All right, so in this scenario, the distance he can travel is going to be equal to his miles per gallon, or MPGs, times the number of gallons. Okay, so D is equal to, let's call it mg. So here, our miles per gallon is 40, and our gallons is 12. So D is equal to 40 miles per gallon times 12 gallons and 40 times 12 is 480. So 480 miles is the distance he can travel on one full tank of gas. So Juan can travel 480 miles on a full tank of gas. Not bad. Now it's your turn to try. Try this. Lily drove a total of 500 miles on G gallons of gas. Express the fuel economy measurement in miles per gallon as an algebraic expression. Give it a try. Example 5. When Barbara uses her car for business, she must keep an accurate record so that she will be reimbursed for her car expenses. When she started her trip, the odometer read 23,787.8 miles. When she ended the trip, it read 24,108.6. Barbara's car gets 32 miles per gallon. Her tank was full at the beginning of the trip. When she filled the tank, it cost her $24.06. What price did she pay per gallon of gas on this fill-up? All right, so the first thing is, let's figure out the distance traveled by Barbara. Okay, so we're going to use her odometer readings in order to determine that. So we're going to take her odometer reading now, 24,108.6, and we're going to subtract her odometer reading at the start, 23,787.8. Now, in case you don't know, the odometer is what you see on the dashboard of your car, and it tells you how many miles your car has driven in its life. So it just tracks it. Kind of gives users an idea of how old and how used the car is, right? So 24,108.6 minus 23,787.8 gives us 320.8 miles. Now that's the distance she traveled. Now we know that her car gets 32 miles per gallon. And remember, D is equal to our miles per gallon, our distance equal to our miles per gallon, times the number of gallons. Okay, so in this case, we have 320.8, 32 miles per gallon times the number of gallons. To solve this equation for G, we'll divide both sides by 32. You can tell it's going to be about 10, but let's get an exact. So 320.8 divided by 32 is about 10.025. Okay, so she used about 10.025 gallons on this trip. Right? Now, when she began the trip, her tank was full. When she filled the tank back up, it cost her $24.06. So in order for her to fill her tank back up, she must put in the amount she took out, right? This 10.025. So we know then that the cost was equal to the price times the number of gallons. All right, so we know the cost was $24.06. And then the price per gallon, which we're just going to put as price, and the number of gallon is 10.025. To get the price per gallon, let's divide by 10.025. Using our calculator, we have 24.06 divided by 10.025, or 2.4, or $2.40 per gallon. So what